UV, CO2, and fiber. Three great laser systems, each with their own superpower, and each with something they can't quite do as well as the others. So, which one is right for you? We're going to kick off with UV. UV lasers are the ideal solution for marking because they use something called cold processing. The shorter 355 nanometer wavelength of UV causes it to break down the chemical bonds of the material that you're marking, a process that crucially doesn't cause it to heat up. It actually changes the material on an atomic level. UV lasers can mark almost anything, especially glass. They can even change the color of silicone without any ablation. Look at the tiny gaps in between the grapes in this logo. The detail and accuracy is astonishing. And there's something else. The human finger can feel about 1/1000th of an inch. And you can't feel it at all. That means no bumps, no cleaning, no harmful byproducts, just a flawless finish. CO2 lasers are great for organic materials like wood, rubber, and ceramic. Biggest advantage of a CO2 laser is it's fast. The spot size of the laser is much larger than on UV or fiber, and the difference can be huge. Depending on the work and the material, a CO2 laser could get the job done 5 times faster than a fiber laser. The trade-off for this incredible speed is accuracy. But if the job was taking powder coatings off of stainless steel bottles, then you don't need to worry about accuracy. You just need those bottles flying off the line. Unlike UV though, this is not a cold laser, it's a hot laser. This hot laser can actually be an advantage. Let's say you're marking wood and you're looking for that rustic, almost burnt look. CO2 is going to do it much better than the cool precision of UV. Fiber lasers are ideal for marking and engraving metals. They are extremely accurate, so you might see these put to work on marking something like a QR code, even onto a metal plate. They are very efficient at converting light into energy, about 50% more so than CO2 lasers, and so they have a low power consumption despite their incredible output. I should say, the efficiency that we're counting here is what you would call wall plug efficiency. Basically, how efficiently is it getting power from here and putting it out here? We do admit, fiber laser systems cost a bit more than CO2 laser systems, and we have some of the best MOPA machines out there. Some lasers will try to get away with only having 1 or 2 pulse widths, when realistically, for good accuracy, you need 5 or more. Our machines offer 17, so you can guarantee they're going to do an accurate job. They're durable too. A good fiber laser, as long as it's properly maintained, could be a solid workhorse for over 10 years. CO2 is great for organic materials, but does struggle a bit with metals and doesn't have the accuracy or longevity of UV or fiber. UV is the most versatile marking laser, and it can mark materials that longer wavelength lasers like CO2 and fiber just can't do. And fiber has the metal marking market on lockdown. They may be more expensive than other options like CO2, but you're still definitely getting the same bang for the buck.